How are you, everybody who is watching this video? I would like to welcome you onto this fantastic session. And my name is Olenjolai from beautiful country that's called United Republic of Tanzania, eastern of the African continents. Here I am to take you from point A to point B of advanced chemistry. So I'd like to welcome you onto our online school that's called Tanzania Online Advanced Secondary Schools in square bracket OLENJOLAIM, where that we use to train students in a different way for the scientific subjects and also mathematics. And then we have our YouTube channels that called Tanzania Online A-Level Circuit Schools in square bracket OLENJOLAIM, where you can find several videos of the session that we've been taught, we've been teaching. And then we have 3 departments in these schools. One is called Advanced Chemistry, second advanced is Advanced Physics, and the third one is called Advanced Mathematics. So in Advanced Chemistry, we are training students Advanced Chemistry for the Form 5 or Class 13s, and also we are training students for Advanced Chemistry for the Form 6 or Class 14. And the main topic that we have today, the subject is Advanced Chemistry. Okay, so Advanced Chemistry Form 5, simply can write that Form 5. And then the main topic is Advanced Organic Chemistry, and the class is for the Form 5 or Class 13. Then the session, this is session 4 of Isomerism, or types of isomers. Because the main topic, that we are learning is called the general introductions of organic chemistry. Again, in case that you feel from your heart now at the beginning of this session, or in the middle of this session, so at the end of this session, that you would like to offer our good a sensitive offering in order to be a part of running cost of these programs, so that we can deliver many videos to thousands students of present and future generations. So you can send your Thanksgiving on this telephone number 0759745331, and your Thanksgiving will be received, and believe me, that is going to perform the specific task in this program. Okay, so before I take you on to this, the concepts of the day, I would like to link this lecture with the previous one. Quick review. Okay, the quick review of session 3. Quick review of session 3. And this session 3 is all about types of organic reagents. Right? So there we ended. So firstly, it means that we introduced to you what the means of the terminology that we call the electrophile. So we told you that electrophile, this is the combination of 2 words. The first one is electro, and the second one is phile. Electro means what? Electrons, and phile means what? Love. So electrophile loves what? Electrons. So it means that it is rich in protons, but it all deficient in electrons, so it loves more electrons as well as we can. So the symbol that we are using in the chemical reactions is this one, right? So this is the symbol 40 of electrophile. Okay. Again, we say that we have 2 types of electrophile, right? You can have electrophile of the positively charged particle, positively charged particle, right? Positively charged particle, and we have different positively charged particles, right? So you have hydrogens, for example, that we give you example of hydrogens, bromine, positive, chlorine is positive, and hence we say that we can prepare chlorine ions, which is positive, when the bond break between chlorine molecules with another chlorine molecules. But one chlorine molecule leaves with the covalent electrons. Again, we introduced to you that that's our positive charge. We say that another example of electrophile is called the second type of electrophile. This we call them Lewis acid. So Lewis acid, these are the acids, or these are the chemical compounds which contain at least 1 empty orbital. So it can accommodate the lone pair coming from the nucleophile. Okay, so this as the example is boron trifluoride. But against another example of Lewis acid is aluminium trichloride, or aluminum chloride, right? And then we talked about free radical. And free radical, we define that a free radical is a group, is an atom or group of atoms that contain one unpaired electrons. Okay? So for instance, that if you have chlorine atoms contain one unpaired electrons. It is what p orbital, right? So chlorine atoms. So in order to show notation of free radical, we say that we use to introduce a dot. That means a free radical. So also you can have a free radical like this one, so but it contains a dot. You can have also another free radical of F, but it has a dot. So these are the two. These are the examples of free radicals: chlorine, methyl, okay, as organic compound, bromide. And then we left it at some of the reactions to you, but that's what actually that you have to think. You have to think, what do you get if you take a free radical plus free radical? And also, can you take a free radical and react with nucleophile? And why? So to summarize, in summary, I think that it's better if I challenge you. So just the summary, let me give you this summary. We say that if you take a free radical and you react to another free radical, for example that chlorine free radical in chlorine or in bromine free radical, this is going to give us neutral molecule. What does it mean? For instance, if we take chlorine as a free radical, another chlorine as a free radical, right? So what are you going to have? You're going to have chlorine molecule, right? And hence again, this is very important. This is not a quick review now, I'm giving you important information. If you take a free radical and you react with what? Nucleophile. This is, according to the chemists, we say that no reaction. No reaction. Again, what if we take a free radical and react with electrophile? So we see that the exception of free radical. If you take any free radical, you react with any nucleophile, no chemical reactions. And also if you take any free radical, you react with any electrophile, then the experiment show that no reaction. So bear this in your mind. No reaction. No reaction. Right? Then number 4. Number 4, we say that if we take a nucleophile and react with electrophile, or if you take electrophile, which is positively charged, and react with what is nucleophile, which is negatively charged, then here there is a reaction. There is the reaction. So one day you'll find this in question exam and you'll remember what I've been telling you. So now, let me take you into the interesting point of the day, which is called isomerism. Isomerism, or types of 40 types of isomers. Isomerism or types of isomers. We have our fundamental questions which is coming for us. First of all, let us understand the phenomenon. What is isomerism? In case you have any question about this, the previous lecture and even this lecture, you can ask in the comment section. What is isomerism? Say isomerism. So what is isomerism? This is the new term you haven't heard during your O level. Isomerism. Okay? So you say that isomerism so isomerism, we say that is the existence of a compound is existence of the compound. Is existence of the compound. Okay? So this the existence, this you say that the existence of the compound in the same molecular formula. In the same molecular formula, but different structural formulas. Different structural formulas. So isomerism means that this is the tendency or the existence of a compound, of organic compounds, in the same molecular form, but different structural formula. Different structural formula. Again, another question is, what are the isomers? What are the isomers? That is the definitions of isomerism. But you can find one of the trick question, which is, what are the isomers? What are the isomers? Right? So you say that isomers isomers are the organic compound, isomers are the organic compounds which have the same molecular formula, but different structural formula. And you will mention some examples soon. So isomers are the compounds which have structural formula, which have the same molecular formula but different structural formula. I may give you one simple example. Example of isomers is this one: CH3, CH2, CH2, CH3. So the molecular formula contains 4 carbons and 8 hydrogen. But also you can have the same, by the same molecular formula, we can have different structure. So you can have the next one here, which is attached, and then you have CH3. Okay? This is CH3, yeah. And then there we have that carbons. Is it true? Okay, these are okay. It contains 4 carbon, so it's butane. It contains 4 carbons and 10 hydrogens. Similar, this one contains 4 carbons. 1, 2, 3, 4. 4 carbons, and then some hydrogens. 4, 7, 10. So these are the isomers compounds. Same molecular formula, but different structural formula. Listen, this is an open chain, we call it, it's a chain. While this one now, it's an open chain, which is a functional group, or we call it skeletal functional group, and then this is substituted group. So the same, why do you say it's the same molecular formula? It means that the molecular formula, for instance, molecular formula of the first C compound contains 4 carbons and 10 hydrogen, right? The molecular formula of the second carbon, it contains also 4 carbons. And how many hydrogens? 10 hydrogens. But the here structure is quite different. Even the nomenclature, if you name it, you see call it butane, right? While this one we call it 2-methyl propane, right? So you have to bear in your mind that when you are saying about isomerisms, what do you mean? So you mean that we are going to teach you compounds, organic compounds, or any compounds which have the same molecular formula but different structural formula. Well, so if that's the case now, I would like to teach you types of what? Types of isomerism. Types of isomers, right? Types of isomers. When you say isomers, bear in mind that types of organic compounds which have the same molecular formula but different structural formula. So there are 2 types of isomers. Two types of isomers that are number 1 called structural isomers, and the second one called geometrical stereoisomers, structural isomers or constitutional isomers. This one we call it stereoisomers. Stereoisomers. So we have structural isomers and stereoisomers. So let us go in detail. According to these contents, we may cover only structural isomers. And stereoisomers, it may be left as homework for you for the private study. Let us go to the structural, or we call it constitutional. Constitutional isomers, constitutional isomers. Constitutional isomers. Structural or constitutional isomers. What are they? That's the first question. What are the structural isomers? What are structural isomers? So simply say that these are the isomers. Okay, as isomers of the same molecular as isomers which have the same molecular formula, same molecular formula, they have the same molecular formula, but they differ in the sequence or order in which the atoms are, in the sequence or order in which the atoms the atoms are attached structural isomers or constitutional isomers. Say it. Structural isomers or constitutional isomers. You have to make sure to remember that name today. And the best way that to remember for the rest of your life, you may call your firstborn structural isomer or isomers or isomerism. Okay, what are the structural isomers? Are the isomers compounds or isomeric compounds which have the same molecular formula, but they differ in what in the sequence or order in which their atoms are attached to each other. Attached to each other. To each other. Okay, are attached to each other. So these are attached to each other. But same molecule, okay, attached to each other. That the full stop. So that is the names of structural isomers. These are the organic compounds which have the same molecular formula, but they differ. They differ in what? They differ in what? In the sequence or order in which their atoms are attached to each what? To each other. Okay? So he said that structural isomers, we have also three types of structural isomers. I won't discuss all of them. I'll just discuss some of them. Types of what? Of structural isomers. Types of structural isomers. Or types of structural isomerism. So you can go to the chemistry book, advanced books, and then you find a page which it has been written as isomerisms. Read it, summarize, write notes, right? Compared to what I've been teaching you, right? So you have to make sure that you are using effectively your textbook. Those textbooks are not like just like we call it just like a flower. No, just like a flower, so that you are pleasing or you are demonstrate that you have books. Then you know nothing about it. That's dangerous. So we said there are three types. There are three types of 40 of structural isomers. Structural isomers. And these are, the first one is called the positional structural isomer. And the second one, we call it skeletal structural isomer. The third one is called the functional structural isomer. Those are the three types of 40 of structural isomer. Okay? So let us learn at least two, and that's the ones I will leave you homework for you. At least take touch a little bit about serious isomerism, then we will see where God will send us. Let us take a look of the first one. Okay? Let's take a look of 42, number 2, skeletal, what is it's called the skeletal isomer, skeletal structural isomer. So define skeletal isomer. Skeletal structural isomer. So what are they? So he said that these are the compounds with the same molecular formula, but differ only in the sequence of the atom in the basic carbon structure. Okay? So skeletal structure isomers, we say that these are the organic compounds. These are the organic compounds which have the same, this is the one of the simplest, the same molecular formula, the same molecular formula the same molecular formula, okay, and dirty and different sequence of atoms. Different sequence. Sequence means arrangement. It's just like sequencing series. Sequence of what? Of atoms. Atoms arrangement. This is atoms of atoms. Sequence different sequence of sequence. Okay. And different of the sequence of atoms. Okay. Along the carbonic structure. Along the carbonic or the carbon structure. When we say that the carbon structure, we mean that the functional group. So this means a majority functional group. Functional group. So skeletal structural isomers are the organic compounds which have the same molecular formula. It means that we can have two compounds. We call them skeletal if they have the same molecular formula, the same number of carbons, the same number of hydrogens, right? But they differ in the sequence, they differ in the arrangement or in the sequence of atoms along the carbon structure. Or they differ that if the atoms, they differ in arrangement of the atoms along the carbon structure, along the open chains, or along the functional group, right? That they mean. So let me give you some examples of skeletal isomers. I have 3 examples of skeletal isomers which are very interesting for you, and they are simple for you to understand. The first one, we say that in case that we have a compounds which is called butane, right? So this is called what? Butane. So this is called butane. Okay? So it's open chain, right? And then another ones, it has the same molecular formula, CH3, CH. Then here we have methyl, and then here we have CH3. Right? So how do we name this one? Even the nomenclature is quite different. So it will be 1, 2, 3. So it will be 2 methyl what? Propane. Right? So this is the example of skeletal. So same molecular formula, 4 carbons, 10 hydrogens, but different, but the arrangements of the atoms or arrangements of the atoms along the carbon structure is quite different. Here you have attached group, here you have no any attached group. Right? All together. The second example again, we can have for another functional group, which is CH3, CH2, and then CH2OH. Yes, CH2OH. So how many carbons are there? 4. How many hydrogens are there? 5, 10. Right? Also, this we call it butanol. Butanol. If you want to show the OH, it means butan -1-ol. Right? Which is common. But also you can have its isomers to formulate another skeletal isomers, the skeletal structure isomer. How do you formulate? You CH3, you CH, and then you have attached the group, and then you have CH2 as usual, OH. Right? How many carbons are there? 4. How many hydrogens are there? So you have 6. Then you have 6, yes, 10. Right? How do we name this compound? Even its nomenclature is quite different. You have attached the group here, and this is the functional group. Should they number from this side, or should they number from this side? Hey! You're naming organic compounds. This is the functional groups of alcohol. Should they number from this side toward this side, or should they number from this side to this side? No. Should they start from this side to this side, or this side to this side? Why? While this carbons is a little bit quiet, okay, fine. The distance is kindly the same, but remember the preference that you have to take here is the positions or the carbons which carries the functional group, which is OH. So we can start from 1, 2, 3, and 1, 2, 3, but this is the preferred because it contains the OH group, right? So this one is called what? 2-methyl propanol. 2-methyl propanol. So those are the 2 examples of 40 skeletal structural isomers. Is it interesting? Tell me in the comment sections if you're enjoying this session, if you're enjoying the beauty of organic chemistry, especially for advanced level. Tell me in the comment sections, you're watching this stuff from which institution, from which college, or from which school, from which regions, from which city, from which country. Okay, so we say that that is about skeletal. So let me take you on to another one which is interesting. Number 3, this sequence that is that you have to follow that sequence? No. So you got the functional structural isomer. Functional structural isomers, very important. I want to discuss this part, and then the positional isomer will be your homework. And the fundamental question always, what is functional isomer, functional structural isomer? Okay? What is it? Wow, so we have definition here. Are the isomers of the same molecular formula but different functional group. Are the isomers which have the same molecular formula and the different functional group. Different functional group. So we say that the functional structural isomers, these are the organic compounds which have the same molecular formula, and also they have different functional groups. So we have to remember functional group. Functional groups of alkane means that single bond between one carbon and another carbon. Functional group of alkane means that it's double bond between two carbons. Functional groups of alkynes mean that triple bonds between two carbons. Function of alcohol having OH. Functions of alkynes have halogens attached to it. Okay. So example. So the way that we can say that for this case we have different types of types of functional isomers. Functional isomers. We like to group them according to the functional group that they share. Right? Functional isomer. The first group, I would like to teach you or give you examples of alkenes and cycloalkanes. Alkenes and these cycloalkanes. So alkenes and these cycloalkanes. So basically for this, how many examples am I going to mention? 1, 2, 3, 4. We'll simply say that there are 4 types of food. Four types of food. So there are 4 types of food of functional isomerism. Every type, when I will present to you, I will give its example. If you're joining me right now, you're warmly welcome. This is Olenjolai, single from beautiful, fantastic country, the United Republic of Tanzania, and you're warmly welcome. We are learning a fantastic session of organic chemistry, one of the longest, was the longest topic for this level. Okay? So then we say that the first thing is alkenes, and what? And the cycloalkanes. What does it mean? It means that regardless of how many number of carbons, or regardless of what the names of that alkenes, we say that alkenes, okay? We say that we have the same number, same molecular form. So 1, then this is alkenes. Alkenes, say cycloalkane, say cycloalkane. So listen carefully. Remember that the functional group, first of all, functional group of alkenes, functional groups of alkene is double bond. So also to have maybe something else to overtake there, maybe like that. Or in general, you can say that this is hydrocarbons and this is hydrocarbons. But this hydrocarbons dash. The functional group of 40 of cycloalkane this is a ring structure. Of cycloalkane. So it's a ring structure. So it is what? Ring structure. But the way it is means that this functional group is just like, let's say you have carbon, carbon, carbon. So single bond, single bond, single bond. So it's the kind of the functional group R1 at different sex of phosphorus. Right? So it's the one, just like that. So examples. So example, let's say that you have propene. So this is what These are not 3 hydrogens, these are 2 hydrogens. So if you write this open structure, it's carbon, carbon, hydrogen, hydrogens, bonds are balanced, hydrogen, 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 hydrogen. So this is the functional group that we are seeing. So in total, how many carbons are there? So its molecular formula is just 3 carbons and then 6 hydrogen. Is there any other organic compounds which have the same molecular formula but different structural formula? Yes. What is it? It's propene. Carbon, carbon, carbon. Right? So between carbons and carbon single bond, so here you have hydrogen, 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 hydrogen. Okay, so even this one is hydrogen. First of all, is that right? It's because there's 2 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right? So then, but this now is called the cyclopropane. It's called the cyclopropane. So even this also tells how many carbons? 3, 1, 2, 3. How many hydrogen? 6. 1, 2, 3, 4, 5, 6. Right? Okay. So if that's the case, now we say that he saturated that ones. So these are the 2 examples. So regardless that you go for between or whatever, you are going to find what I'm telling you here. Okay, so this is a first type of what? Of functional structural isomers. The second type is alkyne. Alkynes and the cyclo. Alkynes and cycloalkenes. Alkynes and cycloalkenes. The functional group of what? Of alkynes. Functional groups of alkyne is this triple bond. It's triple bond, right? Also the functional group functional groups of 40 functional groups of cycloalkene is this. Listen at the triangle here. Cycloalkenes. So cycloalkenes. And then we say that you have at least 1 downward. Okay? So we say that in this one we have only one hydrogen. And then this one contains so this is the functional group that I've been saying. Okay? Functional groups of 40 are fundamental cyclocompounds. And then we say that, let me give you examples. I'd like to give you again simple examples. The first one, C3, CH2, CH2, CH3, so C, H. What is that? Butane, right? Hence, in the cyclic compounds can present the same number. So you have carbons from the two bonds. And then we say that here is supposed to be double. Right? So here we have single hydrogen. You have single hydrogen. Total how many hydrogens do you have? Here we have single hydrogens, single hydrogen. You should have two hydrogens. Two hydrogens. So total you have 60 hydrogen. And here total you have what? 3, 5, 6 hydrogen. You have 4 carbons. Here you have 1 triple bond. Here you have 4 double bonds. Right? So if you write the molecular form of this one is so we say that the molecular formula for this, for carbon, 6 hydrogen. So this is the function, this is cyclobutane, and this is what alkyl. Right? different functional group, but the same what molecular formula. If you count also for this diagram, we have what? Right? So what do I mean? It means that molecular form of this gas is 4 carbons and what is 6 hydrogen. Right? That's the molecular form. So that's the second group of 40 of functional, structural isomers. Then the next group is alcohol and the ether. Ethers. Alcohol and ethers. There's no other there. Therefore, yeah. Alcohol and the ethers. The functional group of alcohol so the functional group of alcohol is what? Functional groups of alcohol is R, OH. So hydroxide is the one that shows the functional groups 40 for alcohol. It says structural group, no functional group. Of ether is R O R hash. Examples. Examples, we say that we have ethanol and ether. Ethanol and what? And the methyl. Methyl ether. Ethanol and methyl ether. So ethanol, for example, the molecular formula is this one, CH2OH. So what the molecular formula? We have 2 carbons, we have 6 hydrogens, and single oxygen, right? Ether, because this is this functional group, what is going to happen? So these compounds will be like this one in the form of ether. So we have CH2. Yes, we have CH3, then we have CH3. So here, how many carbons do you have? 2. How many hydrogens do you have? 6. How many oxygen do you have? Only 1. Right? So the functional group of this one is not like this one. You can write open structure also. Another type of functional is aldehyde. They like to ask many questions in this. Is aldehyde. Aldehyde and the ketones. Aldehyde and ketones. Aldehyde and dirty and ketones. So example, the functional group for aldehyde, this is RH. The functional group for ketones, so this is RH, RH. We learn it later, don't worry, right? So example of this one, in case of CH3, CH2, this is aldehyde, right? Say aldehyde, aldehyde. Then corresponding ketone is CH3, this also is ketone. How many carbons? 3 carbons, 6 hydrogens, 1 oxygen. 3 carbons, 6 hydrogens, 1 oxygen. So then that is aldehyde. So the last group is carboxylic acids. Carboxylic acids. So the last group, carboxylic acid and the esters. Carboxylic acid and esters. Carboxylic acid and the esters, not ethers, esters. The functional group for carboxylic acid is this one. The functional group for esters, it's R or R dash, right? Propanol. Example, if a propanol, CH3, CH2 or OH. This is what propanol. But also we can have the same molecular formula, but we change the functional group, right? From carboxylic acid, and then this guy came like then here we have oxygen, then you have CH3. Molecular formula, you have 3 carbons, it's propanol, propanoic acid. We have how many hydrogens? 3, 2 plus 1, 6. How many oxygen? 2, right? While the molecular formula of this ester, or ester, this will be equal to what? We have 3 carbons, we have 6 hydrogens, 3 plus 3, 6. We have 2 oxygen. Alright? So those are the examples of 40 of structural, of functional structural isomers. I believe that you enjoy the beauty of organic chemistry. Isn't it? Tell me in the comment section, please. And tell me you're enjoying this material from where. So now it's a time to let my students be happy. It means that I'm about to end this session. So they're always happy. You'll find that they are smiling. It doesn't mean that they have understood what I've been teaching them, but because that they like to end things. They like to reach the end. So for instance now, when I say that I'm about to finish, then say finish, sir, finish. We are praying for you, finish. Okay, so you have to do these questions. The first 2 questions, right? Explain with aid of examples. Explain the meaning of positional structural, like the way that I have told you, structural isomers. Second question, you say that also with aid of what? Of examples. Say of examples. Explain briefly the term what? Stereo isomerism. If you do that, we have finished the topic or the subtopic of 40 isomerism. If you answer these 2 questions, then we are done with the subtopic of 40 isomerisms, or in some of the books they call it types of 40 isomers. Briefly, what is the meaning of isomerism? Isomerisms, we say that the phenomena is the existence of one compound, the existence of the 2 organic compounds in the same molecular formula, but different structural formula, right? Different structural formula. So how many types of isomerism do we have? 2. Structural isomerisms and stereo isomerism. And then as we go in detail, we have 3 types also 40 structural isomerism, right? Yeah, so we say we have positional, functional, and skeletal isomerism. The longest one is functional isomerism. But the good thing of it taught also about what are we going to learn in future. For example, carboxylic acid and the ester, right? Alcohol and ether. Alkane and cycloalkane. You see? So those are the examples, so they make you to be familiar and will be the good rounded chemists in terms of organic. So this is the end of this session. I thank God who have been with me during the preparation of this session. I thank God also who have given me strength, understanding, techniques, aids of teaching you what I've prepared today. So I'd like to invite you into the session 5 of organic chemistry, when I will be teaching you about bond breakings, because I want to tell you about what the next lesson after this one. I'll be teaching about bond breaking mechanism, and also I'll teach you about possibly even types of organic reactions. We'll know types of chemical reactions in chemistry, but in organic you have special types of 40 of reactions. So get prepared for that, and make sure that you do the homework, and may God bless you. See you in the next session.